So we have a bit of discussion about the various formulae that we obtained for the projectile motion. When the projectile was projected with an angle of theta 0, the total time of flight we obtained Tf was equal to 2u sine of theta 0 upon g. Also, the range for that angle turned out to be equal to u square sine 2 theta naught divided by g. And h, the maximum height, we found as u square sine square of theta 0 upon 2g. So let me tell you as to what happens to the total time of flight here if theta 0 is 90 degree, and that is the projection is vertical. So for a projection of vertical, theta 0 is equal to 90 degrees and sine of 90 degrees is equal to 1, so it appears to be 2u upon g. So naturally, because sine theta value increases from 0 to 1 as the projection angle is increased, so this value keeps on increasing. So when it becomes in the vertical position like this for the projectile, then the time of flight is more. So time of flight has a dependence on the value of theta naught, okay, and here the range u square sine 2 theta naught divided by g. This will turn out to be equal to, for the condition of the maximum height, we find that the range becomes equal to u square upon g if theta naught is equal to 45 degrees or pi by 4 radians. So this 2 theta naught becomes equal to 90 degrees or pi by 2 radians, for which the sine value is equal to 1. So this turns out to be like this. Also you can see that the value becomes equal to 0 if sine theta is 90 degrees, making with the horizontal theta 0 is 90 degrees, then 2 theta 0 becomes equal to 180 degrees, and sine of 180 degrees, like the sine of 0, is equal to 0 here. Okay, so therefore, and it's very obvious that if thing is projected vertically or upwards, then the thing will fall down also to the same place, vertically downwards. Now, the third situation is that the height that we achieve is equal to u square sine square of theta 0 divided by 2g. So you can see that if theta 0 becomes equal to 45 degrees, then sine square of theta becomes equal to the sine of 45 degrees is equal to 1 upon root 2, and when I square this turns out to be equal to half, and this half multiplied by the earlier value that we have, I will get half multiplied by u square upon 2g. This becomes equal to u square upon 4g. And the same height. Now look here, the correlate between that condition and the condition that theta naught is equal to 90 degrees. When theta naught is equal to 90 degrees, what we get is theta naught square is also equal to 1, the square of 1 is equal to 1, and therefore we get it as u square upon 2g. Look here, this value, when the theta 0 is equal to, the angle of projection is equal to 90 degrees, this is twice the value that we obtained for the maximum height. Okay, so this twice what we get at theta naught is equal to 45 degrees.
Just square it. 1 by root 2 is equal to half. It's like square.
Okay. क्यों बोलते हो यार? So now I want to tell you something more and something interesting as to what happens if the projection at 45 degrees deviates by an angle of delta theta. And in that case, we find, if we carry out the mathematics, if my theta naught is equal to 45 degrees plus minus delta theta, which could be any value you can take and substitute here, then the relation that we had about sine of A plus B, sine of A plus B is equal to sine A cos B, something I introduced to you before, used it also, we'll be using it time and again, is cos A sine B. And with this formula, if I substitute the values that we have, I will write sine of 45 degrees plus minus delta theta is equal to sine of 45 into cos of plus minus delta theta plus minus, okay, cos of 45 degrees sine of plus minus delta theta. Now sine of 45 degrees and cos of 45 degrees both have the same value, and which is equal to 1 by root 2, okay. So cos of 45 degrees r pi by 2 radians is also equal to 1 by root 2, which I did show to you that this is equal to, if I multiply both sides, denominator and the numerator, by root 2, this turns out to be like this, which I can write as 1.414 divided by 2, which turns out to be equal to 0.707. Okay, so that is the value of cos of 45. So cos of 45 I am again substituting here. So I'll get this sine of 45 is equal to cos of 45. This feature I can take outside as a common, and then what is left for me is cos of plus minus theta, delta theta, and plus minus sine of delta theta. Okay, so I think here I don't need to put it like this. Here also I don't need to put it like this. That was in the flow of the pen. Okay, so this becomes equal to 1 by root 2 cos of delta theta plus minus sine of delta theta. So this is theta naught. So sine of 2 theta naught will become equal to, I'll just double this angle and I'll get sine of 90 degrees plus minus 2 delta theta, which again, when I break into the two components, it will be sine of 90 degrees cos of 2 delta theta plus minus cos of 90 degrees into sine of 2 delta theta, and this term will become equal to 0 because cos of 90 degrees is equal to 0. So, and this term here, sine of 90 degrees is equal to 1. So this value turns out to be equal to cos of 2 delta theta. What does it mean? That I will explain to you. Here, then the time of flight. The time of flight that we had here, 2u sine of theta naught divided by g. So for theta naught I am substituting this deviated value plus minus delta theta, and I will get the corresponding result, okay, like this, because sine of plus minus delta theta has already been defined as 1 by root 2 cos of delta theta plus minus sine of delta theta. So these values we can get from the tables, or we can just look into the calculator for the small deviations which are taking place over here. Now, what is interesting is the range. The range was u square sine of 2 theta naught divided by g. So now I write this because the range turned out to be equal to, or u square cos of 2 theta naught, which we obtained over here, because sine of 2 theta naught is equal to cos of 2 delta theta. So I get this relation as r is equal to u square upon g into cos of 2 delta theta. So it appears to me, because u is known to us, we are not changing, g of course we are not changing, the only thing which is changing is delta theta from 45 degrees. So we find that in this particular case, when there is a deviation from 45 degrees, then the r is a function of delta theta. Okay, r is a function of delta theta, and this depends upon cos of 2 delta theta, which is a constant, because cos of minus theta, cos of minus a is equal to cos of a. So that means if my angle is 5 degrees more than 45 and makes it 50, or 5 degrees less than 45, it is equal to 45 minus 5 is equal to 40 degrees. If the projection angle is deviated from the middle of it, then I get an interesting thing that r is independent of the deviation. Okay, whether the deviation is positive or the deviation is negative. So for a deviation of a slight angle, either on the higher side or on the lower side, the range that we obtain for the projectile is the same. Okay. So with the discussion that we had, I would like to reiterate, re-emphasize as to what is the value of sine square of a, or sine square of theta, or whatever angle. So remember, recall that we had a relation, cos of 2a was equal to cos square of a minus sine square of a. Okay, this which followed from cos of a plus b is equal to cos a cos b minus sine a sine b. So this becomes equal to cos square of a minus sine square of a. Now along with that, our identity that sine square of a plus cos square a is equal to, or cos square of a plus sine square of a is equal to 1. We get two results, that sine square of a I can write as 1 minus cos square a, and cos square of a I can write as 1 minus sine square of a. So I can write from here the value of cos of 2a as equal to 1 minus sine square of a, which is cos square of a, minus sine square of a, and so I get it as 1 minus 2 sine a. Similarly, or if I bring it on this side and change it to that side, 1 minus cos 2a divided by 2 will become equal to sine of square of a. And if I want to write cos square of a, then this sign will be changed to minus to plus, so that when we add them up in this equation, the cos 2a terms, they plus minus they cancel, and half plus half becomes equal to 1. So if I substitute this finding, which I reiterate that you must scribble it several times, and then you remember as to what is the value of sine square of a, or sine square of theta is equal to 1 minus cos 2 theta divided by 2, and cos square of theta is equal to 1 plus cos 2 theta divided by 2. So sine square of 45 plus delta theta, the deviation, that turns out to be 1 minus cos of 2 times 45 degrees plus minus delta theta. which is equal to 1 minus cos of 90 degrees plus minus 2 delta theta. Now, I told you that this cos of this 90 minus plus minus 2 delta theta, cos of 90 degrees here plus minus 2 delta theta, this will turn out to be equal to cos of 90 degrees cos of 2 delta theta minus plus sine of 90 degrees sine of 2 delta theta. So this value becomes equal to 0 because cos of 90 degrees is 0 minus plus sine of 2 delta theta. So that I can write this equation as, substituting here, I get the equation as sine square of 45 degrees plus minus delta theta is equal to, like this, 1 minus into minus plus sine of 2 delta theta whole thing divided by 2. And so what I get is minus into minus is plus and minus into plus is equal to minus. So I have this sign over here, plus and minus. 1 plus sine of 2 delta theta whole thing divided by 2. Okay. If I substitute now this to my result for the height h here, which I had here, so I'll just substitute the value and I'll get u square upon 4g because of that 2 factor, and I get 1 plus minus sine of 2 delta theta. So it shows that since u is known to us for a given u and g is a constant, so therefore the system, the height that it achieved becomes a function of delta theta. The one thing is true, that if you look into this relation, then if delta theta is positive, then this is 1 plus something. So this value becomes more than 1, and therefore the height that we achieve in this case will be equal to more than u square upon 4g, because delta theta, the deviation angle from 45 degrees is positive. Maybe 5 degrees, maybe 2 degrees, maybe 1 degree or whatever. But when this delta theta is less than 0, that is, it has a negative value, then of course the height will be less than u square upon 4g, as it is apparent that there is a negative sign here, so 1 minus something will be, of course, a smaller quantity as compared to 1. And then finally, when delta theta is equal to 0, which means that my theta naught, or the angle of projection, is just exactly 45 degrees, then in that case it is u square upon 4g, the value that we obtain. So this is, in the discussion of the things, we obtain a relation like this, and we further go to discuss more about this condition. So I obtained this set of relations. Because I have not taken any numerical values, so we are not able to appreciate what we are doing over here. I found that if there is a small deviation in the value of the angle from 45 degrees, and if it is more than 45 degrees, then we get a higher height, because this expression becomes 1 plus something. And if I have this angle as a negative angle less than 45 degrees, then this height that we achieve is like this. And if the angle is 45 degrees, then it goes like this. So I am going to tell you something very interesting, and that I talk to you about what is scaling. Okay, Now, if I have an expression of the kind where there is a relationship in which y is a function of x, like before, I just take y as a function of x, and I take the very simple case of y is proportional to x. So I obtain y is proportional to x and y is equal to a constant times x. So this we know. Now what if I increase the value of x by say 10%? X goes to x plus delta x, which is equal to x plus say 10% of x. So what happens to y? So y will go to, again proportionally, I can say that y increases by by 10%. And similarly, if I have x decreased by 10%, y decreases by 10%. So this is the kind of scaling that we do. But if I have y is proportional to x square, now it is the square term. So x goes to and y is equal to again some constant times x square. So if x goes to x plus delta x, what happens to y? Y goes to y plus delta y, but x plus delta x square, x plus, it's very simple, it's very easy for you to understand, square. Now this is equal to x square plus 2x delta x plus delta x square. Now if my variation, if my change is very small, say 1%, 2%, 3%, 0.5%, like that, when the value of delta x is very small, then the value of this delta x, for example, delta x is 0.1%, 0.1%. This is the value of delta x. So what happens to delta x square? Delta x square of x is equal to 0.1 into x. So delta x square will become equal to how much? 0.1 squared. 0.1 squared of any percent of, no, let it not be percent of 0.1 of x. Okay, so this will become equal to of, not the percentage, of x, that will be equal to 0. This time it will be x square, so this will be equal to 0.01 into x square. Okay, so whatever, you can see then this delta x square becomes vanishingly small. If it becomes vanishingly small, then I say that this is vanishingly small, so we are going to ignore it. So what is the change? The change in the value of y will become 2. This is the change which is happening over here, and this I can write as 2 delta x into x. Okay, so the percentage that we will obtain is twice that over here. Okay, so it is 0.2% of the value. Okay, now this I can use here. I'll just leave this scaling for another time, but here what I have delta x, and I have the equation is u square upon 2g, the value plus minus u square upon, I'm sorry, not 2g, is equal to u square upon 4g, plus minus, because I have difficulty in looking at such a slanting angle, this is equal to u square sine of 2 delta theta divided by 4g. But this factor, this all is constant. The only variation which is taking place is in the value of sine of 2 delta theta. Now friends, remember and look into it. What I am going to tell you is that sine theta or sine delta theta is approximately equal to delta theta in the limit delta theta tends to 0. It's very close to 0. 0.1%, 0.2%, whatever the value is there. Okay. So sine theta is equal to approximately equal to delta theta, because delta theta is defined in this situation where I have this is the perpendicular, and this one is the arc, and this is the perpendicular. This is my delta theta. So look here, when this delta theta tends to 0, then the arc and the chord are the perpendicular, they become one and the same, and therefore we can write that sine of delta theta is equal to delta theta, and by using the relation cos square theta plus sine square theta, I can say cos square of A plus sine square of A is equal to 1. Therefore cos of my delta theta squared is equal to 1 minus sine square of theta or delta theta, I'm sorry, and therefore cos of delta theta we can write as cos of delta theta as this goes to under root 1 minus sine, I'm sorry, 1 minus delta theta squared. So this will turn out to be equal to, because sine theta, delta theta is equal to delta theta, so this will turn out to be ultimately cos of delta theta equal to 1 minus delta theta square divided the whole thing divided by 2. So this I write here 1 minus delta theta raised to the power half, and this will become equal to 1 minus delta theta square divided by 2 divided by 2. So this is the square relation of this kind. Y is equal to this kind of a variation, and the other one is x into this kind of a variation. Therefore, what I mean to say is, what kind of question we can put to you? We can say that suppose h is the maximum height, and if I make a small percentage change in the value of this angle from 45 degrees, then the rise in the height goes by half a meter. So what will happen? If instead of increasing the value of delta theta 45 plus, if we decrease by the same amount, what will happen? The height will decrease by the same amount. So this can be an objective type of question, and more so because this is scaling requires another couple of lectures for you to do. We'll return to that. And now I take up a few examples just to see as to how we can use the knowledge that we have gained in solving a few of the problems. So the first problem, which might appear on your screen, it will pop up on the screen, is something like this. I told you that the problem has to be defined in our own words. So there is a question, and the question is like this, and that will pop up on your screen. Okay, what we have is, and this question is regarding the value of the range, which we know, which is u square sine of 2 theta 0 divided by g. Now what is given to us is, we know the value of r. R is fixed, r given, fixed, yani given. The range is known to us, and then we have to find u minimum. U minimum. What is the minimum velocity of projection, so that I can obtain the range? Okay, I can obtain the range. Okay, the range is, therefore we have to find out the value of u minimum. What we have from this relation, I will obtain that u square is equal to rg upon sine 2 theta naught, whatever. Now, in order that this result be minimum, r is fixed, g is fixed, so only this thing is changing. If this thing is changing, then this is minimum and this is maximum. It's a very simple argument. That means maximum value of sine theta, sine of 2 theta 0, this value, this maximum, what is it? All of us know by now, remember that this is equal to 1, which gives sine of 90 degrees. So which means that this gives us that theta is equal to 45 degrees, theta naught is equal to 45 degrees. So in that situation, to find out the value of u minimum, when I put the value, fix the value of sine of 2 theta naught as equal to 1, I obtain the range u as equal to, simply by substituting over here, I'll get this equal to Rg or gr divided by 1, which is equal to Rg. Okay, under root, because this is the value of u minimum square. So this is equal to under root Rg, and of course the unit will be meter per second. Okay, so for a definite r, we find out the minimum velocity with which the projection has to be done. The projection has to be done with 45 degrees of angle, and this turns out to be like this. In the second case, another one, I take up, there is another question, again depending upon this range. The next question that I take, which will appear on your screen, it reads like this, that a bullet fired at an angle 30 degree with the horizontal hits the ground 3 kilometers away. By adjusting its angle of projection, can one hope to hit a target 5 kilometers away? Assume the muzzle speed to be fixed and neglect air resistance. So I say the same problem in my own words by taking this range equation here and describing the projection like this. This is the initial velocity u, and the angle here I have taken angle is equal to theta 0 is equal to 30 degrees, and then it hits, the range is 3000 meters. So what we have to do and what we can do is, now this range is variable as the angle of the projection is changed. Okay, so I have been given the target, new target 5 kilometers away. So what I have to determine is very simple, and what I have to determine is that the maximum range possible, and if the range possible is more than 5 kilometers or equal to 5 kilometers, of course we can adjust the angle. So let us see as to what happens and what we can obtain. So what we can obtain is that range maximum, range max is equal to u square into sine of 2 into 45 degrees, which is equal to 90 degrees, which is equal to 1 divided by g. Okay, so this is what we get here, the maximum, and this is equal to u square upon g. Okay, the nozzle velocity is a constant. Okay, the u is a constant, so I'll get this one, and we are going to calculate as to what is the value of u square upon g from the first case. So in the first case, what we have 3000 on the left hand side is equal to, u is fixed, so u square sine of 2 theta naught, and theta naught is equal to 30 degrees, so sine of 60 degrees divided by g. Okay, so therefore this relation gives us the value of u square upon g. Now the two values are fixed. This is equal to 3000 divided by sine of 60 degrees, and the sine of 60 degrees is root 3 by 2. So here I divide it by root 3 and this by 2, so this turns out to be equal to, 2 will go up, 6000 upon root 3, which will turn out to be equal to 6000 meters, root 3, I multiplied by root 3 in the numerator and the denominator, and this turns out to be equal to 3. I divide this 6000 and this turns out to be equal to 2000 root 3, and the two values of, we ought to remember, okay, because we don't have any calculator. So here I told you before that root 2 is equal to 1.414 and root 3 is equal to 1.732. Okay. In Urdu, this is 14 and this is 17. So that way I remember it. So this turns out to be equal to, if I multiply by this, so this is equal to 2 into 1732, which is equal to 3464 meters. So the maximum range that I can obtain is 3 kilometers 464 meters, which is definitely less than 5 kilometers. So therefore, whatever I do, I am not going to be able, because the nozzle velocity is unchanged. So if we want to really hit the object, then we must have another gun with another nozzle velocity, etc., etc. Now, I go to the third question. Okay, in the next question we have H given, U given, and we have to find out R max is equal to what?
Read the question.
Okay, so now these can have any values. The values you can see in the question that is going to appear there on your screen. How do we do that? Now you can see that H is equal to, there is a formula for H. H is equal to U square sine of square theta naught sine square of theta 0 divided by 2g. So this is the equation from where we start, and from here therefore I can say that sine square of theta naught is equal to, this is equal to 2gh divided by u square, so that sine theta naught becomes equal to under root of this relation 2gh upon u square, like this. And so I can write that the value of cos theta naught, again using the same identity, cos square a plus sine square of a is equal to 1. So this will turn out to be equal to under root of 1 minus sine square of theta naught, that is equal to, when this is squared, 2gh upon u square, like this. And this is, then we substitute in the value of r. R is equal to the maximum value of R max, I can write as U square sine 2 theta naught upon G, and this is equal to 2U square upon G sine theta naught cos of theta naught by expanding sine of 2 theta, and the values I can give, what we obtain as the value of sine of theta naught is equal to like this, cos of theta naught is like this. We substitute these values over here and we can calculate the value of the range. So what I can, like in the thing, height is given, U is given, the only value which is R max has to be calculated, which is calculated like this, the final value being 2U square upon G, like this. And these calculations need be, you can take the value of G as equal to 10 meters per second, just for the sake of estimation problem that you have. So here I stop. You have many other questions which exist, which relate these quantities, how the maximum range is associated with the maximum height, and how the deviations take place, which I have done today, what is the time of flight, etc. And all these features, once you have, you scribble down every question and you find an answer. Because the answers have to come from the set of relations that you have for the time of flight, for the maximum height, and also for the maximum range or whatever range is there. So for today we stop here, and the next topic that we are going to discuss is tomorrow, and the next lecture thereafter we are going to talk about the angular velocity, this thing in the uniform circular motion, non-uniform circular motion, in the end, etc. Okay, bye for now.